Assume that it costs Apple approximately C of x equals 400,000 plus 160x plus 0.001x squared dollars to manufacture X32 gigabyte iPhone 6 in an hour at the Foxconn Technology Group. How many iPhone 6 should be manufactured each hour to minimize average cost? What is the resulting average cost of an iPhone? How does the average cost compare with the marginal cost at the optimal production level? Give your answer to the nearest dollar. We are given the cost function C of x, and we are asked to minimize the average cost. So this is an optimization problem. The unknown quantity in this case is the number of iPhone 6 that should be manufactured. The objective is to minimize the average cost. So the first thing we'll do is we need to come up with the average cost function. Recall that the average cost C bar of x is the cost function divided by x, where the cost function is given 400,000 plus 160x plus 0.001x squared divided by x. We simplify this as 400,000 over x plus 160 plus 0.001x, where x is the common denominator, so we take every single term in the numerator and divide it by x. 400,000 divided by x, 160x divided by x give us 160, and 0.001x squared divided by x give us 0.001x. We now have the objective function, the average cost. The next step is to find the derivative of this average cost. The average cost prime, the derivative of 400,000 over x is 400,000 times the derivative of 1 over x is negative 1 over x squared, where 400,000 is the constant multiple. The derivative of 160 is 0, and the derivative of 0.001x is 0.001. Simplifying this, we have negative 400,000 over x squared plus 0.001. And again, this is now the derivative of the average cost. Before we find any critical number for this function, observe that the derivative is not defined when x is 0. If x is 0, then we have 0 in the denominator. However, this is not a critical point because the average cost has x in the denominator. And so the average cost function is defined when x is not 0. Also, since x is the number of iPhone, then it cannot be negative. This means we're dealing with x that is strictly greater than 0. Next, to find the critical number, we will set the derivative equal to 0 and we solve for x. These will be stationary points if there's any. To isolate x, we first move 0.001 to the right hand side, so we obtain negative 400,000 over x squared equals negative 0.001. We then rewrite negative 0.001 as a fraction by putting the 1 in the denominator. Then we can cross multiply. Negative 400,000 times 1 will give us negative 400,000. And then negative 0.001 times x squared will give a negative 0.001 x squared. We then isolate x squared, which is negative 400,000 divided by negative 0.001. This will be a positive number for 1, 2, 3, 4, 5 zeros on the top, and we divide it by 0.001, so we end up with another set of 3 zeros. So there are 8 zeros total in this number. The square root of x squared, or the square root of 4 with 8 zeros, will give us 20,000. The square root of 4 is 2, and the square root of 10 to the 8 will give us 10 to the 4th. So this is 20,000. This is the number of 32 gigabyte iPhone 6 that they should manufacture in an hour. Now, how do we know that this will minimize the average cost? If we pick a number in the interval 0 to 20,000, let's say if we pick x equals 1, and we plug this into the derivative, we will see that this will give a negative 400,000 divided by 1 plus 0.001, which means the derivative will be negative on this interval. And similarly, if we pick a number in the second interval, let's say if we pick 30,000, then we plug into the derivative, we will see that negative 400,000 divided by 30,000 will be less than 0.001 with a negative sign. And so this will give us a positive interval in the second interval. This means the average cost is decreasing and then increasing. This means there is a minimum value at 20,000. What is the resulting average cost of an iPhone? Now remember that this X is the number of iPhones manufactured. If we want to find the average cost, we would need to plug this back into the average function, but this time we plugged in 20,000. And so C bar of 20,000 is negative 400,000 over 20,000 squared plus 0.001. And this will give us $200, and this is $200 per iPhone. This price per iPhone will give us the optimal production level because we optimize the average costs. How does it compare with the marginal cost? To answer this question, we will need to find the marginal cost, but remember that the marginal cost is derivative of the cost. We take the cost function, which is 400,000 plus 160x plus 0.001x squared, which is the numerator of the average cost here, and we find the derivative. The derivative of 400,000 is 0. The derivative of 160x is 160, and the derivative of 0.001x squared is 0.002x. We plugged in 20,000 units into this marginal cost to get 160 plus 0.002 times 20,000, and this will give us $200. What this means is that at the optimal production level, the average cost is the same as the marginal cost, and that is $200 per iPhone.